electrostatic discharge, and 10 myths that could be wreaking havoc on your project reliability and even your development schedule. Welcome to Unboxing Tomorrow, covering projects in electronics, robotics, and communication systems. Electrostatic discharge, or ESD, is a hazard I mention often, and the anti-ESD packaging that we can find protecting components is something I featured in a previous video. It also showed what might happen to those components if you handle them without being grounded by an ESD strap or something similar. In this video, I'll be covering 10 myths that are circulating about ESD, typically from people who are not using ESD countermeasures. Now, this video is not a potshot against developers who are not using ESD countermeasures, but it is going to highlight some of the decision errors that could lead to a device being mishandled or suffering an early life failure. To give you that list uninterrupted, I'd like to first thank my affiliate TorGuard VPN. VPNs, or virtual private networks, can help reduce your online exposure to malicious hackers and cyber criminals. TorGuard VPN is the VPN that I use for this purpose, and you can help the channel and your privacy at the same time by checking out the link in the description. Use promo code UNBOXING for additional discounts. The first myth, which I hope is also the most controversial, is it's never been an issue. Unfortunately, this one often gets circulated by professionals and even a few researchers who have some direct exposure to electronics without the explicit training in ESD or VLSI reliability. It's also common among PC enthusiasts, and it usually follows the structure of, I've been building PCs for ages and never had an issue. I've been doing this or that for 20 years and never had an issue. Logically, this is sort of like going on a hike in the woods and then claiming that you never stepped on an ant the entire time. It's simply easy to miss things we aren't looking for, and besides being anecdotal, it ignores latent effects that may not even cause a noticeable problem until months or even years after the equipment goes into service. I covered some of these effects in the earlier video, and previous experiments, while dated, did use split lot production, which showed correlation between lax ESD controls and higher failure rates. Myth number 9. ESD is for semiconductors only. While the ESD problem has been around for quite some time, it really garnered attention with the development of MOSFET technology. This type of transistor uses an insulating metal oxide layer, which becomes an unfortunate weak point when the structure experiences a static shock. However, even non-semiconducting components, such as certain foil resistors and certain thin film resistors, can have their thin films damaged. Moreover, when a fully completed circuit board is powered on and operating, touching it without proper grounding can radiate noise throughout the system. These emissions might then activate edge-triggered logic, causing erratic behavior. Dedicated EMC test facilities even purchase ESD guns to try and induce these device upsets inside a controlled environment. Myth number 8. ICs have adequate protection built in. This one actually has a little truth to it. So far, 21st century integrated circuits do often incorporate ESD countermeasures inside them called voltage clamps. These clamps are designed to switch on in the presence of a high voltage pulse and bear the brunt of the ESD strike before it can reach something more sensitive. So why does this have myth status? Very often, these ESD protections are really meant to protect only against foundry processes and the packaging process. These are often engineered against the human body model or the charged device model, which, while better than nothing, aren't really going to hold a candle against the type of ESD strikes that you or I could generate simply by mishandling a part. Myth number 7. It's too humid. This is another one with some truth to it, and there are many predictive models and ESD studies that show that yes, humidity does have a mitigating effect on the likelihood of an ESD strike and the amount of damage it might cause. But humid weather isn't a guarantee, and the electronics labs of developed regions are usually climate controlled anyway. The more reliable solution is to simply use grounded equipment, including mats and ESD straps. For example, this ESD strap here cost only about $5 or $6, and it makes humid or even dry weather practically irrelevant. Myth number 6. Rubber shoes will prevent it. This myth is caused when people accidentally conflate static electricity with electric current. Insulating materials like rubber, styrofoam, most plastics can gain their electric charge using tribocharging, which happens when two surfaces of different composition rub against each other and exchange electric charge. While tribocharging isn't the same as friction, the two often go hand in hand, which is why we usually suffer the worst static shocks after walking across materials like carpet. This is also why Van de Graaff generators use rubber belts and similar materials to shuttle electric charges from the generator into the metallic top load, where we can see the effects of high voltage. Myth number 5. There is no ESD. The unpleasant electric shocks that we would feel after touching that Van de Graaff generator is generally an indication that the peak voltage was in excess of 3000 volts. Contrary to popular opinion, there are surprisingly high lower limits to the ESD voltages that a healthy adult can actually sense. That voltage limit is somewhere around 3000 to 3500 volts, depending on the pulse width, and this is clearly a far cry from the absolute maximum ratings of things like microcontrollers, which may have an upper limit under 10 volts. Combined, these two facts suggest it's very easy to unwittingly damage electronics and subject them to thousands of volts without being able to see, hear, or feel a thing. Myth number 4. Circuit board assemblies are largely immune. Like the others, there is some truth to this, because many engineers and their designs do use devices like metal oxide varistors and transient voltage suppressors that are meant to counteract ESD, but to assume that every single net will have adequate protection is actually a composition fallacy, and even the most ESD paranoid design probably isn't going to put suppressors on the entire net list. A common rebuttal is that the natural capacitance of a circuit board trace and ground planes will absorb the shock, much like a conventional capacitor can absorb a short pulse of electricity. Again, there is some truth here, but this is also circumstantial, because self-inductance has the effect of converting sudden current pulses into high voltages. It's something I'd like to cover in a future video, but for now I can only say that this is circumstantial, and you're probably better off not taking the risk. Myth number 3. Touching metal beforehand will stop the risk. Touching a large metal object, or a grounded conductor such as a water pipe, will temporarily discharge you, but let's also pause and account for how tribocharging works. As soon as you're disconnected from that grounded or large metallic object, you're going to start moving through the environment, meaning that there's nothing to stop you from accidentally replenishing everything that was drained away. I used to make this assumption myself, usually touching a grounded object before work began, and after many months of trying this and damaging sensitive equipment, it was obvious that it just didn't work. Again, the safe alternative is to simply use a cheap retractile strap, connect to it before work begins, and disconnect after work ends. Which actually brings me to myth number 2, ESD controls don't need to be plugged in. Although I see it less often, occasionally I'll walk into a location where there are ESD mats in place, and yet the mats aren't actually bonded to anything, or even each other. The purpose of these mats is to redistribute charges and slowly bleed them away until the entire work surface is at the same voltage. The same holds true for grounding straps and grounded equipment. The ESD risk is lowest when they're all connected electrically. And the final myth, materials don't matter. I've saved this one for last because I think it's the area where the industry has seen the most improvement over the past decade. Insulated packaging material poses a greater ESD threat than materials that are dissipative, and we can usually find these ESD-safe materials either marked as such or using the blue or pink color scheme. This is a good thing, because dissipating materials don't tribocharge nearly as badly as general-purpose plastics. Shielding bags actually take this a step further by forming a Faraday cage around the contents. More developers seem to be using them, which is an awesome sight to see. So that's it for now. If you've ever had any unusual experiences with ESD strikes, let me know in the comments, and consider subscribing so you won't miss the next update. The monthly poll for March 2021 wants to know if you invest in cryptocurrency or anything crypto related. Stay posted for the next update, and as always, have a great day.